We're going to talk about the methods for analyzing fibers. So if we get a fiber like from a crime scene and then we have control fibers, what do we do to kind of compare them and see if we think that they're the same? What tests do we run? The first thing that you can do is microscope observation. So that'll be your first technique. The technique is to view the fibers that you have, both the unknown and the controls, under low and high power on the microscope. And you're looking for the following things. You're looking for the weave pattern. Okay, so is it plain? Is it twill? You're doing a fiber description. What does the fiber look like? Does it look like plastic? Does it look like a natural fiber, synthetic? Any distinct characteristics, color, etc.? And obviously you would want to compare that, the unknown with your controls. The next test that you can do is a burn test. The burn test, the technique for doing it is to hold the fiber over a hot flame and record the observations. You can even use something as small as a candle, like this girl's doing right here. So she's got the fiber right here and you hold it. Usually it's best to go near the flame, stop for a little bit, see what it does, then put it in the flame and see what color it burns, see how quickly it burns, see if it catches on fire. And then you want to pull it away and see what it does when you pull it away. What happens to the residue, what's left over, does it smoke, etc. So some observations that you want to record while you're doing the test. Okay, odor. What does it smell like? And you want to be specific. You don't want to say things like good or bad. You want to say, you know, it smells like campfire, or it smells like vinegar, or it smells like burning hair, etc., etc. Okay, the more specific you are, the easier it will be to compare later. The color of the flame produced. Some fibers, when they burn, like olefin, will produce like a greenish flame when they're burned. The color of the smoke, is it dark black, is it gray, etc.? And then the appearance of the residue formed afterwards. Is it grayish? Is it darker, etc.? So those are the observations that you want to make when you do a burn test. Okay. Again, here's just a little bit kind of more in detail. You want to wear your safety goggles. You want to take a bundle of fibers from the fabric only, put them close to the flame. Here are some things to observe when you get them near the flame. Okay. When it nears the flame, does it light easily? Does it smolder? Does it pull away from the flame or shrink? When it's actually in the flame, is it smoky, yellow? Does it sizzle? Does it melt? Does it drip? Some of them will drip. Behavior when you remove it from the flame. Does it continue to glow? Does it continue to burn? Does it go out right away? What does it look like? And then here's your odor, which we kind of already talked about, some descriptors for that. You always want to make sure when you're smelling the burn samples that you waft the fumes towards your nose. You never want to directly smell them, because some of them smell bad and will burn your nose. And then any ash or residue, okay, and we kind of talked about that. When you're finished, you would obviously take your candle and you would blow it out. The third test that you can do on fibers to analyze them is you can compare the unknown fibers with the control fibers using chemical tests. The technique that you use is that you use different chemicals to test their solubility, and solubility is the ability to dissolve. Okay, so you're going to test its ability to dissolve and the decomposition of the fiber, meaning how does it kind of decompose into its original parts. Observations that you want to make when you're taking a look at the different fibers and different chemicals is, does it dissolve or not, meaning does it completely go away? Does it turn different colors? If so, what colors does it turn? And does it make what's called a precipitate? A precipitate is like a solid. It's kind of like a solid substance, although most of the time the solid substance looks kind of like goo. Does it make like a pasty glue type of thing? But that's what you're looking for. Okay, and then you would want to obviously write all those observations down. The fourth test you can do is what's called a thermal decomposition test. The technique behind it is that you heat up the fiber. Because fibers are polymers, meaning that they're small units linked together, if you heat them up, it breaks those polymers down into their original monomers. And the monomers that make them up may be acidic or basic, and that's what you're testing for in a thermal decomposition. So thermal means heat, and decomposition means to break down. So you're using the heat to break down the polymer into its individual parts. So what you do is you take a small piece of fabric and you put it at the bottom of a test tube right here. Okay, and then you wet both blue and red litmus paper. Red litmus paper turns blue if a substance is basic, and blue litmus paper turns red if a substance is acidic. So you wet both using distilled water, and you put them on both sides of your test tube. Okay, you don't want them to touch. And then you're going to take 2 to 3 drops of lead acetate, and you're going to put it on filter paper and put it over the top. And then you're going to heat it up. And the idea is you're going to heat up your fiber until it breaks down into the monomers, and then those monomers, if they're acidic, they're going to turn your blue paper to red. If they're basic, they're going to turn your red to blue. And if they have any sulfur in it, they're going to react with the lead acetate and make a blackish compound. So the sulfur will make a blackish compound with the lead acetate. So that's what you're testing for. You're testing to see what properties the monomers of the polymers have when you're doing a thermal decomposition test. The fifth test that you have the option to do is a refractive index test. The technique is to measure light as it passes from air into a solid or a liquid. In this case, your solid is your fiber. Okay, so you're taking a look at the light passing from air into your fiber. So the light's going to slow down as it passes into your fiber, and you're looking for what's called the Becky line, or the Beck line. The Beck line is a halo-like shadow that appears around the edge of an object when it's immersed in a liquid of a different refractive index. So if this is your fiber and you see the Beck line on the outside of your fiber, it means that it's in a higher refractive index than the liquid. It's bending more light than the liquid that it's in. If you see the Beck line on the inside of your fiber, it means that the fiber has a lower refractive index than the liquid, meaning that it's bending less light. Your goal is kind of for the fiber to turn invisible. No Beck line is present. It kind of looks like everything just melds in together because the fiber and the liquid are bending the same amount of light. So you can't see a Beck line, and sometimes it makes the fiber kind of turn invisible too. That means you have the same refractive index. The liquid that you have it in is the same refractive index as the fiber itself. So that's how you do that test. The last test that you can do is you can do chromatography. The idea behind chromatography is that you can take the dyes that are in the fibers and you can separate them, and then you can match them up to an unknown. So when different fabrics are dyed, they're dyed using the same components. If you were to separate them out into their original base colors, ideally 2 fabrics that were in the same batch should have the same base colors, and you can separate them out and so that you can see that. So the observations you're looking for is that the color separates as it moves across the paper, and you want basically your unknown and your known, the colors to end up in the same spots, because that means that they would be dyed with the same materials. So when everything's dyed like a red, some of those base colors, or a black, right? Black will separate out into several colors that were mixed together. And sometimes they use, more red than blue or more yellow than red or whatever, and you can separate it out and you can see, and 2 blacks might look different. If it's 2 of the same blacks, they'll have the same chromatography paper. They'll look the same. Okay, so you're looking for the colors to spread out, and then you're looking for the colors to spread out the same way. So you can run any of those tests, and you can use those tests then to see if your unknowns and your controls are the same, and that'll give you kind of more probabilities of them being the same the more tests that they have in common.